Okay, so now today this set of the video is for the intro to algebra chapter 7 challenge problem. Now let's start. So the first, a man is walking. Okay, a man walked a certain distance at a constant rate. If he had gone half mile per hour faster, and we work the distance within the 4/5 of the time. If we walk half a mile per hour slower, and he will be end up with 2.5 hours longer. So now let's draw a picture and set up equations. So you don't know the speed, you don't know the length, and you only know the relative speed faster and the relative time, right? So let's set up equation with the reference first. Okay. So half a mile faster, half a mile slower. We have to have set up with the reference. Okay. So let's set up is the original distance x miles and the original speed. So we can have the x over v equals t. Right. This is our relative. It's the first standard. Now if we can move half a mile faster, we can use the 4/5 of the time. And we can move half a mile slower, we end up with a longer time. Okay, so now let's see. Okay, so it tells you something 4/5 of the time. It tells 4/5 of the time or the hour, but it also tells you the half mile faster, half a mile per hour slower. So what I feel, my thinking is using the v and v plus half and v minus half to set up the relation is easier. So that's why I rewrite the equation, okay, as this. Four, 5, 6. Okay, now let's see how we can use this one to set up the equation. Okay, first, what I'm thinking is, did you see all the x is on the numerator and the denominator is kind of weird, right? So we can try to keep all the x's and try to cancel it. So that's why let's observe it. So 5 plus 6 equals 2 times the 4, right? 2v adding together equals 2 times v. So we have the 2x over t equals to 5x over 4t plus the x over t plus 5 over 2. Right? So we can cancel the x. Then you can see we have the t on the denominator, t on the denominator. We can try to combine these two, right? So that's the 4/3 of the 1 over t is equal to 1 over t plus 5 over 2. Then we can solve the t is equal to 15 over 2. Once we solve the t, right, the goal is we want to solve the x. Once we solve the t, let's see how we can solve the x, okay? So still considering about this, right? So we want to use the t to solve the x, and we have the v, right? In this case, we want to eliminate this v, right? How we can eliminate the v? We can use the 5 minus the 6. So we can have 1 equal 5x over 4t minus x over t plus 5 over 2. So then you can apply t equal 15 over 2 on both sides, on both terms. So now you can see x equal to 15. Next, According to the U.S. Census Bureau, the world's population passed 6 billion people in July the 18th, 1999, and further, the average of is the 4.2 births and the 1.7 deaths occur every second. So if those rate will remain the constant, in what year will the population reach the 7 billion? It's a rate, right? So this one is basically is the time equal to the number of population divided by the rate. Okay, now let's see the population, right? The population is 7 billion, increase from the 6 billion. So the difference is 10 to the 9, right? And let's see the rate. The rate here, it tells you it's 4.2 birth means more people, and the 1.7 death means less people, with a net of the 2.5 people per second, right? But we are asking what? We are asking the year. So see, in what year, right? So we want to converting this one to the year. How many people per year? Okay, you can think 2.5 people per second. It must be more people every year, right? So it will be 2.5 times, let's see how many seconds in a year, okay? 365 days and 24 hours per day times 3600 seconds per hour. Okay, so this one equals right. So you have the 4 and the 6. So this is the 10. So this is the 10. Okay, so it's the 365 times 6 times the 36 times the 10 to the 3. Okay, now we have this amount of people increase every year, right? Now we can calculate the t, here is the year, right? Equal to the 10 to the 9 over 365 times 6 times 36 times 10 to the 3, so equal to the 10 to the 6 over 365 times 6 times 36. Then you can see it's 12 point something something. Okay, so that means after 12 years we still not achieve the 1 billion increase yet, right? So it must be 1999 plus the ceiling of our answer is equal to 1999 plus 13 is 2012. So in the year of the 2012, we can achieve 7 billion people. Next, the tail of a 1 mile long train exit a tunnel exactly 3 minutes after the front of the train has entered the tunnel, right? So now let's see, because there is a train has a length, right? So we need to show this case, okay? So here is the train is 1 mile long, and the tunnel is the x, right? The train comes in and come out, right? So train has come in and come out, right? So we need to put a single reference point on the train, okay? If we put to the tail, we need to put the tail. The tail travels the point to the point are corresponding travel the same distance. So here you can see this point travels x plus 1, right? Is equal to how many miles it travel in 3 minutes. So we travel the 60 miles per hour, right? So 3 minutes is over 3 over 60 is in hour, right? So basically this point travels 3 miles. So that's why x equal 2 mile. Next. Suppose the train leave from the New York for Atlanta, okay? Here is the train leave from the New York to Atlanta for Atlanta every 20 minutes starting from the 1 a.m. So the starting time is 1 a.m. plus half of the n, right? Every, 3 n over 3, right? Because it's every 20 minutes. And the train leaves from Atlanta for the New York every 30 minutes starting from the 1:10 a.m., right? So it's 1:10 a.m. plus the every 30 minutes is every half an hour, right? That's every 1/3 of the hour, 1:10 a.m. Okay, so if it takes 10 hours to travel from one city to another, okay, that means if this is the 0 hour, then after at this point, right? Let's take the point on the as the x-axis, right? So this is the 10 hours. So how many trains are traveled from the Atlanta to New York? From Atlanta to New York, okay, how many are passed by a train leaves at New York at 1 p.m.? So we have a train A leave at New York at 1 p.m. Okay, let's see. The first train from Atlanta at 1:10 a.m., right, arrived in New York at what? At 11:10 a.m., right, plus the 10 hours. So that means when the train A leaves, right, okay, it's all piled up with the trains from the Atlanta to New York. So the first train it will experience before it leave, right? The first train from the Atlanta to New York. Let's use the cross let's use the square as the train from the New York to Atlanta. Okay, let's use the dot as the train from Atlanta to New York. The first train is 10 minutes away, right? So it's 1 over 6 hours away, right? Next train is plus half an hour, right? It's 4 over 6, so on and so forth, right? And also there will be trains here, okay, that has not departing from Atlanta yet. But once the train A takes time to move, right, all those trains will land on this solid spacing. They are the solid lines. They are going to leave Atlanta. All those trains also can be passed by the train A, right? So now let's see. The question becomes 10 plus x over 2, the x trains, right, every half an hour, right? And it takes train A 10 hours, right? Minus 10. It's 1/6, I'm sorry. So the first train is 1/6 away, right? So 1/6 plus half an hour minus 10 should be less than 10. Means all this number of trains, they are going to leave the Atlanta over the 10 hours. So now let's solve it. It becomes x over 2 is equal to the 20 minus 1/6. That means x should be less than 40 minus 1 over 3. So that means x can be ranging from 0, 1 up to 39, right? So if x can range from 0 to 39, means there is a total of 40 trains, okay, that can be passed by the train A. Next. Okay, so Jenna and Jeannie are 20 miles from the home. Okay, so they have 20 20 miles from home, and they have they have one pair of the rollerblades, and Jenna walks 4 miles and skate 9 miles. Jeannie walks 3 miles per hour and skate 8 miles per hour. Then they started from the for home at the same time. First, Jeannie had the rollerblade and Jenna walks. Then Jeannie skate for a while, then take off the rollerblades off and start walking. When Jenna reached the rollerblades, she put them on and start skating. Wow. It's just we need to digest the process, okay? So this is the 20 miles. This is the home. Okay? So we have two persons, Jenna and Ginny. Okay? So they each have two speed. The Jenna walks at 4 and skate at 9. The Ginny walks at 3 and skate at 8 miles per hour. So first, Ginny has the rollerblades, right? So at a certain point, X, Ginny has the rollerblade, and Jenna is work. So now let's see, we have each has two sections, right? So in the first section, okay, Ginny has the rollerblade. It takes her X over 2 hours, right? To finish the X miles. It takes Jenna X over 4 hours to finish the first X miles, right? Then the rest of them, they switch, okay? So Jenna can skating 9 miles per hour. This is how long does it Jenna finished the 20 minus X. So the Ginny finished the 20 minus X using this, right? So they mentioned they start at 4 o'clock and arrive home at the same time. If they arrived at home at the same time, they start at the same time, means this is the time, and this is the time of the Jenna use and Ginny use should be equal. So now let's set up equation. Is X over 4 plus the 20X over 9 is equal to X over 8 plus the 20 minus X over 3. So we can solve it. Is X over 8. So this with the X numerator, this numerator with the 20 minus X is equal to the 9 over 2 20 minus X. So now we can solve X equals 60 over 5. So we know this section. Okay, so we know this section is 64 over 5 miles, right? Now let's solve the time. So the time is equal to X over 4 plus the 20X minus 9. And we can apply X equal to 64 over 5 into the equation, plug in. And then it will give us the 4 hours. It used 4 hours to travel. And the starting time is 4 o'clock plus the 4 hours. So they end up getting home at 8 o'clock. Okay, next. The Superman and Flash are running around the world in the opposite directions. The Superman running around the world, right? So it must be a circle. The Superman can go around the world in 2.5 hours, and the Flash Man can do the same thing in the 1.5 hours. So they travel around in the opposite directions, and assuming they're starting at the same time and same place. So they're starting at the same time, same place, starting from the reference point A. How many times will they pass each other to going in the opposite direction? In 24 hours. So the Superman go here, okay, and the Flash go here. You know the Superman is one cycle takes about 2.5 hours, means the Superman speed is every hour it travels this amount of cycles, right? And the Flashman speed is faster, this cycle per hour, right? Because they go in the opposite direction, right? They go in the opposite direction. So when they meet first time, every time they meet, it's a full cycle, right? So every time the distance of the Superman travel from the distance plus the distance of the Flash travel is always the integer cycles. Okay, so this is the key. Now let's see. Okay, so let's see what's the first time they meet. The first time they meet is one cycle, right? Over 1 over 2.5 plus 1 over 1.5, right? So because the Superman move here, the Flash move here. So when they meet, it's a full cycle. So they meet earlier. So this is the first time. How many times about one cycle? Okay, now we can calculate it. The time for each cycle, okay, is equal to 15 over 16 hours. So now we know when they first meet, okay, it takes 15 over 16 hours for them to meet every cycle. So over the 24 hours, right? How many cycles is equal to how many meet they can do in 24 hours, right? So it's 24 times 16 over 15, right? So it's equal to the 128 over the 15. So we need to take the number of integers. We need to take integers of this number, right? So it will be the floor function is equal to 25. Okay, so that's the end of this section first.